In the following example, we're asked to find when a rocket that has an altitude given by this equation hits the ground. So if we think about hitting the ground, that means the altitude or the height reaches 0. So we want a time for the height to be 0. To do that, we need to find the root of the equation, which we're going to do using Newton's method. Now, to use Newton's method, we need an initial guess. We need to find the functional value at that guess, and then we need the functional value at the derivative. We use this formula to solve it, or to find the next guess. In this case, we want 5 decimal places, and as you see here, I've already filled in most of the solutions since it's just a repetitive procedure on the calculator, and if you watch the previous video, you'll see that it does take some time, so just to speed it up, we're going to have the answers there, but we'll show you where they all came from here now and do the calculator steps. So we need the derivative, so let's write the derivative. H prime of t is equal to negative 6t squared plus 168, 2 times 84, t plus 480. So there's the derivative. Now we need a guess. So if you look at the graph here, this is the graph of the function, it doesn't show us any positive roots. We're looking for time, so we want it to be positive, so we need to find where it crosses the x-axis over here. If we zoom out, which is number 3, and we hit enter because we're zooming out from the origin, there's our negative root, and still no positive root, so hit enter again to zoom out further. And here you should see a root right here. We have no idea what value this is. We've just zoomed out twice, so we need to use the trace feature to scroll over. Now here's our cursor, but because our graph kind of goes way down and way up, it's going to be hard to follow. But if you just pay attention to the y values here as I move the cursor to the right. Positive, 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 bigger positive, still going up. And still going up, still going up. Now it's starting to come down. I'm talking about the y values here. Down. And then it's negative. Notice that? Positive, negative. That means we crossed the x-axis. That means the root is somewhere between 44.2 and 47.6. 0.66. So, because negative about 3,000 is closer to the axis than 12,000, we're going to estimate that the root is somewhere around 47. So our initial guess is going to be 47. Now we need to find the functional value at 47. So we put 47 in here to find the answer. And we're not going to use the graph like we did in the previous video to do that. We're going to use just the home screen. I'm going to label each of these A, B, and C. That means this is A minus B over C. We're going to use these terms in the calculator here. So what we're going to do is we're going to say 47, and we're going to store STO that to alpha A. So now A is 47 in the calculator. To find B, we have to put A in for each of these t's. So we're going to do negative 2 times A to the power of 3 plus 84 A to the power of 2 plus 480 times A plus 10. And we're going to store that answer to B, because that's the functional value at 47, which is A. We hit enter and we get the answer is 480. So we'll write that in. It's 480. Now we need the derivative at 47. So we're going to do a similar thing using the derivative this time. So negative, let's see if we can put that, negative 6 alpha A squared plus 168 alpha A plus 480 And that we're going to store to C. So that's what we're going to put here. So our C value then is negative 4,878. Now this number comes from taking A minus B over C. Now in the calculator they are A, B, and C, so all we have to do is do A minus B over C. And here's what's going to make this fast now. We're going to take this answer, and what do we do with this? This comes back over here to be A. So we're going to take this result and store that back to A. So it'll be a new A value. And the number you get is this one that I've already written here. Now we need to find B. So how do we do that? We need to put A in for each of these. But we've already done that on the calculator. So if you hit second function entry, or enter, the last line you typed came up. But we don't want this line. We want the line that was up here for B. So we do it again. Gives us the line for C. We do it one more time. Here's the line that we found B with. Now remember, we have a new A value, so this is going to be the calculation we want. Enter. There's our answer. Now we want C. Second function enter. There's B. Second function enter. There's A. Second function enter. There's C. So that's what we're looking for next. So C is, there it is. And now we need A. So there's the one for C, for B, for A. Enter. And there's that one. And that's already stored for A. And now we can just do the exact same thing. Now we need to find B. There's the one for B. Here it is. Write it in. C, second function enter, second function enter. We need to find the one for C. There's the calculation for C. Write it in. And now we need to calculate A again. So second function enter, that's the one for C. For B, there's the one for A. And there's our value for A. You have to do these in order to do this right, because remember your value for A is storing over and over again, and then you're using B and C. So make sure you do find, you pick your A, you get your B, you get your C, you do this to find A, B, C, A, B, C, A, B, C. And it's a nice quick way, especially if there's more than 3 lines here. We know we can stop now because we need 5 decimal places. We have 0.980106. We actually have 1, 2, 3, 4, 5, 6, 7 decimal places here. But the answer to 5 decimal places would be 47.09801. And that's when the rocket would hit the ground.